Hello, everyone, and welcome to a live episode of the Rugged Edge Survival Guide, a Premio podcast. I'm your host, Daniel Litwin, the voice of B2B. And folks, thanks so much for joining us on another episode of the show. We appreciate you listening along to some broader rugged edge and edge computing thought leadership. As we explore today's topic, make sure that you're heading to our website, premioinc.com. Again, premioinc.com, as well as subscribing to the Rugged Edge Survival Guide on Apple Podcasts and Spotify. We've covered plenty of topics concerning evolutions to the rugged edge, evolutions to edge computing, and applications for edge computing in various industries. So you'll definitely want to catch up on some of those perspectives. Again, you can find those on Apple Podcasts and Spotify. So on today's live episode of the show, we're drawing some important distinctions on what we mean by the edge when we talk about the edge. Like we've explored on the show before, in an era of distributed computing and data-intensive business operations, it makes a lot of sense to process data at its source, at the network's edge, right? But since these business operations differ so much by industry and use case, the edge itself is a bit of a wide area coverage and is hard to lump into just one singular definition. So today, we're digging into the two core distinct categories for edge computing today. That would be the near edge and the far edge, and why it's important to develop some computing strategies for devices both on your factory floor edge as well as miles and miles away in the most rugged of environments. So for insights as we explore this difference between the near and the far edge and how that should play into your edge computing strategies, we're joined by frequent guest and contributor, Mr. Dustin Seetoo, Director of Product Marketing for Premio. Dustin, great to be chatting again. How you doing, man?
I'm doing all right. Thank you for having on again. I'm excited to be here to kind of provide some thought leadership based on this campaign that we've been talking about for over the past year.
Yeah, absolutely. It's, again, a real pleasure to be chatting again. And, just something I want to emphasize again is that, in case our audience doesn't know, Premio was very much at the forefront of defining the rugged edge as a core standard definition for this evolution of computing into difficult high-strain environments, as well as very far from the network, but closer to the source of that data collection. And so now we're hoping to bring that same energy into further defining what we mean by the edge, and again, defining that near and far edge distinction. So, Dustin, I want to start with a little refresher on some key statistics around the rugged edge today. I'm wondering if you can give us basically a state of the union on where it's at in terms of scale and use cases in today's environment.
Yeah, so edge computing, right, is all about just moving all this processing power as close to IoT sensors, because that's where you're able to extract the data. That's where you're going to build the intelligence. But from our perspective, I still believe it's early on in kind of the thought leadership and the growth of that, because we're still waiting on some very key technologies that I will dive into in this podcast. But specifically, I kind of want to start kind of with some statistics that really are driving the market that we've been talking about for the past few years, right? So a lot of industry analysts, and Gartner to be specific, has made a pretty big statement that I like to include in a lot of my thought leadership discussions, is that 75% of data is going to be processed outside the cloud by 2025. So if you take a time to kind of think about that, I mean, that's a lot of data, 75%. And that's very, very important for me kind of to learn about this statistic, but also to kind of build that into our strategy, is because it really shows the importance of data and the value of why it's going to grow the business intelligence that's really shifting this data that's closer to the data generation. But a question I think a lot of people are probably asking, right? Why is this is decentralization that's happening away from the cloud? And it's definitely not because the cloud is not doing its job. It's definitely because the cloud is a bad resource. It's really an ability to really drive the proximity of data closer to data generation. So a good example would be, during this pandemic that we've had, the cloud was a major resource that everyone relied on to be able to run their daily operations. So that clearly basically specifies that the cloud is not going to go anywhere. So where edge computing continues to grow, and it's basically just natural physics to where you want the processing power, right? Because if you had to do a lot of this data processing by sending it back to the cloud and relying for it to come back, number one, the latency would be way too long, and definitely number two would be kind of unreliable. So kind of to stitch that all together, right? What are those technologies that are coming to fruition? What are those technologies that will only continue to grow that we're waiting on? And those two key technologies would be 5G, which is on the horizon, right? All the telecom communication carriers, they're all talking about their 5G rollouts, and then really stitching it together with edge compute, right? So I think those two major things are really going to drive the synergies for these new business models and really drive the intelligence, right? So another important topic to kind of dive into, right? When I talk about all this data that's being generated, there's going to be three distinct primary locations where this digitization is going to happen. And those three locations, number one being the core. And when I define this as the core, these are your traditional cloud data centers, your enterprise IT data centers, your server farms. And this is where you can use the cloud resources in a controlled environment to really drive the intelligence trained models. A second place where you're going to have digitization of data is what we continuously are talking about, which is the edge, right? And the edge is a very unique place because you're sometimes deploying a lot of these devices in environments that might not be as stable. So you need to have the rugged reliability. And oftentimes in these enterprise hardened systems, they need to be able to deliver real-time processing to aggregate the data, store the data, and basically distribute the data from the endpoint to the processing device all the way back to some type of local type of data center. And the last type of place would be the endpoint. And this endpoint would be basically a lot of IoT sensors that are being put together and are really pushing out to the network to drive the data generation. So one final statistic I kind of want to talk about is really all this data, right? All this data from all these three primary locations. A lot of the industry analysts are basically saying that's going to grow to about 175 zettabytes, and 75 zettabytes are really going to come from IoT devices alone. So you can kind of get a sense in terms of this explosion of data that will continuously be able to grow over time.
Yeah, and that compounding effect of having data captured at those three tiers is obviously exciting, and it's important for our audience to understand how that differs in different edge applications. Again, whether that's the far edge, the near edge, which we'll get into here in a second. As a follow-up here to basically your State of the Union, I'm curious how the data pipeline is responding to some of this mass data intake. How is it currently set up, for better or for worse? Where does the data have to pass through across the rugged edge? How are some of those smaller things changing? And why is that an important thing to keep in mind as we continue our conversation today?
Yeah, so again, those three primary places where the digitization of data is going to happen, and that basically facilitates through what I'm calling kind of a data pipeline. Right. And if you look closely kind of at this chart and then what we have, I think it clearly helps visualize the process of data and how the data needs to be moved at which specific location all throughout the pipeline. And I think this specific diagram and chart, in my opinion, does a great job defining three key things of why data growth, why data explosion, how data is being used in the wealth of compute is going to be important. I think number one is it really shows where data based on the device is being generated, and then at what stage it really gets to be moved out and out further and further away from where it's being generated. So on the left side of the diagram, you have your mobile IoT endpoints, you have something that are more local, right? And then as you move farther out to the right, this is where you have your traditional private public type of clouds. A second thing I think this chart really does a great job on defining is really defining the edge communication latency. So when you talk about edge computing, one major topic that always comes into discussion and always talks about the benefits is the overall latency. So being able to see where the data is being generated, what type of processing power you need, and the type of latency it actually needs to have in order to be successful and reliable is extremely important to really understand the huge data pipeline. And then the third, you can kind of get a sense of when you're able to determine your latency, you can now distribute what's most important for your machine learning models that are going to help grow for artificial intelligence. So closer to the left side of the diagram, once you have your models trained, this is where you can now use software to run your machine learning algorithms through inferencing models. And these inference models are very accurate because they've already been trained in the cloud to where you'd be able, for example, to recognize objects with pretty good accuracy. And then as you go closer to the right, you can leverage all these amazing, powerful cloud resources that are able to really train these deep neural networks and really kind of push a future for artificial intelligence.
I appreciate that breakdown there. Just as our last recap here before we get into that true definition of near versus far, can you recap for our audience as well how Premio is defining broader edge computing and how Premio has positioned itself as a player in rugged edge computing? So I guess as a sub-question there, we'll start with what is rugged edge computing in Premio's eyes, and how does that determine where you place your technology investments and your product development?
Yeah, so I think in the beginning of this year, we were still in kind of in a pandemic. And I think what we really wanted to do was identify some educational thought leadership in what we were seeing with a lot of the problems that our customers were dealing with. And basically, long story short, we were able to take the hype, or I would say take the benefits of what edge computing's discussions were talking about and really kind of grow something into what we define as rugged edge computing that's going to be beneficial for our audience, our target customers, because that is what we and our engineers are putting together in our products and solutions. So, in that journey, we learned that many of our customers are really still in their own version of what we are calling, their digital transformation. And in that digital transformation, right, they are trying to figure out ways to access their data, collect their data, store their data, and really push forward some type of insight from that data. So really what rugged edge computing is defined as, and really kind of builds off of what edge computing is that it's this shift of all this localized compute power closer to where data generations are, whether that be IoT sensors, and being able to leverage the processing power and connectivity to really drive actionable insights for incredible speed and accuracy, but in the harshest environmental conditions. So really, if you ask me and you ask pretty much anyone in the Premio family, we really define rugged edge computing as the convergence of the latest IoT technologies that is driving compute, storage, connectivity, and then really taking a look at our products, computing products, from a system level type of ruggedization, because we understand that in a lot of these newer type of ultra low latency environments that are remote, mobile, the product really needs to be ruggedized and being able to deliver reliability in these type of environments. A second thing would be decentralization away from the cloud resources, because you just don't have that bandwidth available for the type of application to run anymore. So being able to take kind of all this technology, putting that into dedicated hardware and system level engineering, and pushing forward a balance of like power efficiency, the ruggedization, connectivity, we really are able to kind of define and provide computing solutions for a lot of our new customers and a lot of their newer applications to meet their digital transformation.
I want to hone in on a few other things there. Part of what supports Premio's place in the edge computing world is a ecosystem, I guess, of key technologies that are also shaping edge computing work, the data flow, and how reliable edge computing can be for these different use cases. So I'm going to break a few of those down and would love to hear how you see those influencing Premio's definition of edge computing and some of the differences in the distance of edge that we're talking about, which we'll obviously follow up here in a little bit. So again, one of the key technologies that is evolving alongside edge computing is cloud computing. I'm wondering if you can touch on some of the migration trends to the cloud, how that's impacting our conversation today.
Yeah, so I would say there are a few key technologies that I want to kind of talk about. If you stitch them all together, that's really going to help define the beauty of edge computing and kind of the benefits that's going to provide. So speaking towards the first point, cloud computing, I would say it's one of the most important technologies, because over the past decade, it's been proven to actually be a pretty robust platform of what it is providing in terms of resources, computing power, storage power, and all these type of things. But I think let's kind of take a step back to really identify why cloud, which I've talked about, has some type of limitations in the edge, and why that's a major element of edge compute. In the cloud world, and a lot of the experienced cloud vendors, what they usually always will talk about, and what they always will kind of mention, and what they actually define in the last decade, is this cloud native environment. And when we talk about a cloud native environment, in a very simple way, it's basically being able to virtualize a lot of the different processes and just not rely on just bare metal type of servers. Because once you're able to have the virtualization of the products, you can now be very strategic in how you run your applications with that. Taking a step back in terms of what cloud native is, let's talk about, I think, what's important, some of the milestones of how the cloud came to be. So if you kind of think about the cloud as a whole, right? What it was in the very beginnings of that, and there was this push to virtualize a lot of this traditional, hardware resources that you had to do on your own, and move it into a centralized location that can be shared across a lot of different enterprises, a lot of different applications. And this is what was defined as infrastructure as a service, or infrastructure as a service in a virtualized environment. So just to kind of recap, it's really taking all the networks of storage, the memory, CPU, and putting it into a centralized location like a data center, and allowing different applications or being able to use that without actually using it on your own on-prem type of storage, right? So this is where the cloud grew into a lot of these major cloud vendors that everyone's familiar with. You have your Amazon, like AWS, and then obviously your Microsoft Azure. But I think that growth as a whole in centralized location actually pushed forward to the second milestone of where the cloud was. And I would say it's not only are you virtualizing the infrastructure, now you're able to now virtualize specific hardware based on the operating system. So not only is the infrastructure now virtualized, you're now trying to virtualize a lot of the processes, the operating systems, network, memory, file systems. And what this does, and the key benefit of this, is really providing the isolation and segregation for the application itself, right? To run virtually on the same virtualized hardware. And this is where, if you talk to a lot of people about the virtualization, you'll hear a lot about the ability to run your containers, right? Because once you have a virtual environment, once you have a virtual processes, you can basically stick your application in a container, and that can be kind of multiplied amongst multiple containers to actually be run in an isolated environment as well. So being able to have the virtualization in the environment, being able to virtualize it with some type of container in that environment is a huge, huge benefit on why cloud computing is very important for the next type of edge compute. I would say, kind of to segue into that, right? What is another major transformative technology? I would say that ties into the cloud is really about 5G, right? The rollout of 5G, which is pretty much it's coming, and a lot of the carriers are really pushing out their 5G. So how I look at 5G, and I kind of like to use an analogy that's pretty easy for anyone to understand. I picked this up through the pandemic. I had a friend during the pandemic decided to pick up baking. Never baked anything before. So he told me, and he went through kind of all his stories about baking. He learned how yeast, when you mix it with flour and like the starch and sugar, right, that actually helps the bread rise, right? So I kind of use that analogy in the sense of what 5G is doing for edge compute, because once you're kind of throwing a lot of this 5G technology, it kind of stitches everything together. And what 5G is really, as everyone knows, right, it's the 5th generation of wireless technology. And it's providing key elements of what connectivity is able to happen. So in terms of like speeds, right, you have data rates up to 20 gigabit, right? And then that's the uplink, and then you have 10 gigabits on the downlink. So if you compare that to kind of 4G speeds, right, you're getting 20 times faster data rates, you're getting lower latency, and all that is kind of what's kind of shaping all this compute power connectivity at the edge. But specifically talking about 5G, and kind of to help the audience understand, when I say 5G, there's actually different elements of 5G and why it's so important. And in 5G, you have what's called like these different spectrum bands. So just from a general understanding, you have your low band spectrum, mid band spectrum, high band spectrum, and then going back to kind of the low band spectrum, this is that kind of nationwide type of coverage, right? It's sub 1 gigahertz. And this is what a lot of the major carriers are kind of pushing when they say they're 5G ready, because it's more low spectrum band and it's a sub gigahertz. And this is really good for kind of that wide coverage, but it's limited in speed, right? And it's good in terms of providing that overall 5G coverage layer. If you move it into that mid-band spectrum, this is actually where you kind of go into more metropolitan areas where you're going to get a little faster coverage, a little bit more speed to deliver the gigabit type of speeds required. And this covers that spectrum level about between like 1 gigahertz and then 6 gigahertz. But really where I think 5G is going to explode and what everyone continues to kind of focus on in terms of the benefits of a spectrum that's going to provide is really in this high band spectrum. And this high band spectrum, what's also known as millimeter waves, is really a very unique element of a spectrum that's going to be dedicated for a lot of these new edge applications, because it's going to be run in a different type of gigahertz or spectrum with between 24 and about 100 gigahertz that's going to provide high speed, very, very low, ultra low latency environments that's going to deliver that real time. So if you kind of look at 5G as a whole, like it's not about how fast it is. I think it's all about opening up new opportunities for these new applications, right? That can really, really define that real-time processing in this unique millimeter wave band spectrum.
And the last technology I wanted to get your thoughts on here is AI, right? Artificial intelligence, machine learning. There have been several deployments over the last year and a half that have enhanced edge computing and rugged edge computing in response to some of the efficiency crunches brought on by the pandemic. Give me your thoughts on where you see AI being at today, and then we'll get into the meat of the conversation.
Yeah, so before talking about AI, there's also some key, I would say, pillars in that 5G discussion that I'm talking about. It's going to really kind of not explode, but help AI continuously to progress and move forward. So some key pillars of 5G, I mentioned it earlier, but I want to be specific and kind of helping the audience understand. When we talk about 5G and that millimeter wave, there's also like ultra reliable, low latency communication. And this is that very, very low, or low latency in terms of processing time that provides the sub 1 millisecond latency that provides the reliability in terms of 99.999%. Right, so that in terms of reliability, they're actually even calculating in terms of the 10,000ths of how reliable that can be, which is going to be huge. So, for example, some of the applications that do require millisecond latency, that everyone will basically be able to stitch together because it just makes sense, right? Robotics need to be able to recognize, be able to react very, very quickly, or there's just going to be delay and nothing's going to happen. Autonomous vehicles is another great example, right? If in a 5G network, if you have that ultra latency environment, autonomous vehicles can now make split decision decisions, right? And that's going to prevent a lot of the safety things. A second major pillar of 5G technology would be kind of what's called as enhanced mobile broadband. And that is the next evolution of what current LTE is. And this is going to provide enhanced gigabit speeds, right? So data rates up to 20 gigabits of downlink, 10 gigabits of uplink. And this is another great example of this would be currently right now, if you try to download a 4K video, it'll take some time because you're still using the 4G LTE connectivity. But with 5G, you can pretty much download a 4K movie in less than 30 seconds, or even able to stream thousands of videos simultaneously. The last key pillar of 5G would be massive machine type communications. And this is where IoT is going to explode, because not only do you have all these devices coming online that have all this data, now they can communicate with each other. And they're going to be communicating with each other on this millimeter wave band, right? And that's going to provide in a very, very like 1 square or over about a half a mile away for these devices in a small type of environment to really communicate and really deliver insights. So when I say like a small environment, because right, like I mentioned, millimeter wave, it's not great in terms of when you have to do like wide coverage, but in a very small environment like a factory environment or robotics, where you need to kind of be able to have these devices communicate and build kind of like this closed loop of autonomy. That's where this massive machine type of communication is going to benefit. And then the last kind of thing that stitches everything together, and I think it's a benefit of 5G and like edge compute, and when you have all this data and you're able to kind of do data manipulation, is something that I've discussed before in my past podcasts, is something called the digital twin, right? So a digital twin is basically a carbon copy of the physical asset in a digital version. So if you kind of think about what that provides, is that now provides a way to basically either run type of workloads, run a proxy, make some changes on the digital asset before actually affecting the physical asset. Vice versa, in terms of that data from the physical asset, and that can basically be processed, analyzed, and provide insight to actually provide risk aversion or just maintenance. So the last, I would say, kind of to dive into the last major technology, and what led this discussion is where does the artificial intelligence kind of take into play, right? So artificial intelligence is going to take all this cloud compute, it's going to take all this 5G technology, it's going to put this all together based on a way to deliver machine learning models for these newer applications. And I think there are some key driving factors that are going to make a lot of this intelligence and compute occur, right? So number one, there's current and constant advancements in a lot of this semiconductor technology. So when I talk about semiconductor technology, this there's like multi-core CPUs that are diving into like neural network processors, system on chip designs that are being packaged in like very, very small die form factors, and that are very specific for AI workloads. And a lot of them are becoming more energy efficient to be able to drive out further away in these remote environments. So think about GPU, which is your general processing unit, versus your tensor processing unit, which is a TPU, right? So when machine learning was growing and when you had to use all this horsepower to drive compute, the first solution was to use what was pretty common in terms of performance power, which was GPUs. So GPUs are the same type of GPUs that people are using to play games in their gaming rigs, but it's just used on a different application because GPUs itself naturally have more and more cores, right, than just a regular CPU. And you can use a lot of those cores to run machine learning models very quickly. But there is a downside to using these GPUs because these GPUs as a whole use an enormous amounts of power, right? So as you move further away in terms of environments where you don't have constant stable power, it becomes a challenge. And in these advancements of semiconductor technologies, you're now able to use what they've created. Google created this was TPUs of smaller form factors that are specifically dedicated to really run these machine learning models in a very, they're extremely powerful in terms of its tops, but it's also very power efficient. Another element would be, I would say, there are these new computing architectures that are taking place. And when I talk about computing architectures, right, x86 platforms as a whole, which is it's a Premio's kind of focus and bread and butter from compute all the way out to GPUs. And this is basically going to pull all this together in terms of solutions that can do the model training, data manipulation in the cloud to really build out these deep neural networks. And then when we talk about new computing architectures, you also can't talk about you cannot talk about PCIe. PCIe in terms of compute architecture is extremely important because it really it basically builds out the I/O throughput and how the buses are communicating and how data transfer rates are happening. So just to kind of share, and people who are familiar with the industry, the next generation of PCIe is at the Gen 4.0 transfer speeds, right? So as all this compute, storage, and connectivity options move to that PCIe Gen 4, that speed actually doubles in terms of what previously generation was the Gen 3. So then essentially you have, like, for example, a PCIe 4.0 by 16 bus, about 32 gigabytes per second, which is extremely beneficial for a lot of this new compute power. And then the last thing in terms of AI would be kind of the open source of software and development of the symbiotic relation between hardware, right? And I've said this again in multiple podcasts, right? The software is written in a way to really drive the flexibility for the application, but it's also written in a way to where it relies on hardware to deliver the horsepower, the performance acceleration. So having that open source to really have the symbiotic relationship for software and hardware is going to have a major benefit in terms of compute as a whole.
And with that, let's go ahead and jump into the differences between the near edge and the far edge. Again, in this context of how the market and how technologies are currently driving edge computing. So as a refresher for our audience, or maybe this is the first time that they've made this distinction, but the near edge is made up of things like the Internet of Things appliances that you might have in a factory, right? They're not super localized. They are spread out across a facility, but they are still relatively near to where the data has to then feed back to for analysis and for strategic decision making, stuff that's relatively close to home. The far edge is going to be your very remote devices. These could be 5G base stations, or some of the most rugged edge deployments in some of the most difficult environments we can imagine. Very hot, very cold ones. The range is rather limitless. But now with that basic definition out of the way, what would you say is the ultimate goal for decentralizing specific workloads into a near edge versus a far edge, instead of treating the edge as one giant environment?
Yeah, so that's a great question. And I think there's not a single answer to basically solve that, but I think the simple answer that's easy for everyone to understand, the ultimate goal is basically being, based on the application, moving compute, networking, storage resources in specific locations in proximity to where it's being generated to really figure out a way to dramatically cut down the time it takes, which is the latency, and really provide this new ultra low latency type of performance in terms of the application as a whole. But ultimately, I think when you have all these resources that are stitching together, right, just as a recap, cloud, 5G, AI, this really opens the door for a lot of these new applications. So for example, you have your mobile robotics assembly, you potentially will even have autonomous drone delivery. And then even on the intelligent transportation side, you have all these POCs that are happening, but these autonomous fleets, vehicles are starting to actually become driverless, and they're basically going to be delivering things, back and forth.
Now, on top of that, how does this improve the flow of data then when we have a more distinct strategy for near versus far edge? Does this improve the flow of data or the efficiency of each kind of workload to make those kind of distinctions? Yes, no, why or why not? How do you see that panning out?
Yeah, so I think looking at that chart again, right, is a very clear identifier in terms of the improvement of workflow, because based on either the device, based on the location, based on its latency requirements, based on its machine learning requirements, you can decipher and you can basically determine what is the most important type of solution that needs to be there to basically access the data, process the data, right? But I think, again, these workloads, the newer workloads that do require, millisecond latency that are less than 5 seconds is really where you're going to see this major growth.
Yeah, that's very important to keep in mind, because as these use cases become less of a, hey, let's try this workflow out, let's see where we can maximize edge computing, but as it gets validated and turned into a standard for various industries, I think it's going to be important to further define, okay, what kind of workload are we really working with here? How much power do we need in our edge computing solution? Is there anywhere where we can, be more thoughtful with our investment, and can that guide our deployment strategy? All of that's going to be made way easier if there's a better understanding of a near edge definition, a far edge definition, and how those workloads differ. So yeah, great point there. Now let's circle it back around to some of the innovative and cutting edge technologies that are moving in tandem with the growth of edge computing. That would be things like the growth of 5G and cloud computing and AI, like we mentioned. Can you touch on some innovations in that multi-access edge computing world, but how this is impacting workflows in the near edge and the far edge specifically?
Yeah, so again, there's the reason why you have these specific locations like far edge, near edge, is because you have dedicated resources for that application to run there. So one key innovation that's also dictated by a standard is called multi-access edge computing. And multi-access edge computing is basically a combination of the 5G networks, right, and cloud computing. I think a good place to kind of start about this, when you think about cellular connectivity, or if you think about how that data is being processed, right, all these telecommunication telcos have their towers that are kind of dispersed all throughout the nation, providing this different type of spectrums, right, that I talked about between low, medium, and now high. But traditionally, you did not need to provide the cloud computing resources at that base station because the cloud was the cloud. It was already reserved in the data center to do what it needed to do. But what's happening now, and it's very, very interesting to see with this multi-access edge computing, and based on what I kind of talked about in terms of this cloud native model, where you're kind of being able to virtualize a lot of this information and virtualize a lot of these applications, and in a very serverless type of environment, is you're starting to get a lot of hardware solutions that are deployed now kind of like at the base stations of these telcos. And then when we talk about these base stations of telcos, they're really kind of like cloud mini data centers or nano data centers that are distinctly being used to interact with the 5G networks in a virtualized environment that has the cloud native type of resources. So think about that for a second, right? Now having all this type of cloud resources sitting close to where these telcos have their base stations and really driving that 5G network so close to where data is being generated from the IoT sensors is going to provide an enormous amount of ability for a lot of these newer type of ultra low latency type of applications as a whole. So yeah, I think 5G is extremely exciting, right? If you kind of see where it's going to go and how it leverages multi-access edge computing in proximity and all this compute and resources, I think the future is very, very bright in terms of compute as a whole.
Last but not least, let's start to chat about how Premio fits into this ecosystem then. You already did a good job towards the beginning of the podcast breaking down for us where Premio is defining the rugged edge and how that influences not only your products, but also just your understanding of where these products need to be put to use and how workflows differ across the edge. So let's get a little deeper here then. How does Premio fit into the ecosystem for both the near edge and the far edge data pipeline? And I'm wondering if you could break down your portfolio of things like embedded solutions, HPC solutions, and where the dots connect again at the near and the far edge.
Yeah, so if you kind of take a snapshot of that data pipeline that I've been showing kind of throughout this podcast, right? Towards the left, you have your IoT sensors. And this is where the data is being generated. This is where you need that localized processing. This is where you need to run your inference models for real-time detection, mobile robotics, things that are very ultra low latency. This is where I would say Premio is positioned in terms of our rugged edge computers. And the solutions that are needed at the rugged edge are very unique in the sense that there is this demand for more processing power, storage processing power. That's going to drive what I've talked about in past podcasts that I won't go into is this hyper automation for real-time insights, because with hyper automation, you're basically leveraging machines that have the situational awareness, that have cognition to make decisions in a very, very quick manner. Second, I would say on that left side of that field in terms of solutions that are being delivered, you have these new software algorithms that are being created and being more flexible, but that need ruggedized hardware to drive the performance to deliver the real-time detection. So a lot of our new solutions are designed and engineered to package the latest performance hardware into a system level that are able to withstand a lot of these harsh environments, whether it be wide temperature swings, shock and vibration, power instability, things of that nature. And the third, I think, would be providing a need for what traditionally everyone was comfortable in terms of data center performance at the edge. I say that with a grain of salt, because you're never going to get the data center performance directly sitting close to the data or at the edge. But when I talk about data center performance, I'm strictly talking about the hardware side of it, and you're able to kind of take a lot of these technologies from the data center and just move it into a hardened system that has been tested and verified to actually drive these newer type of compute models. So I think what the market really demanded, and what it did, is that it kind of forced engineers to kind of think outside the box, kind of think outside their comfort zones, because these computers, or these rugged edge computers, are being pushed into uncontrolled environments where you really need to be able to balance that power efficiency, but really push the limits of the reliability for this performance. So having access to a variety of these new semiconductor technologies, like I mentioned, compute architectures from CPU, GPU, even TPU, right? You're really able to deliver the performance that's needed to actually drive that application for real time. In addition to that, right, you have all this storage capacity, right? And that storage is going to be huge, because you need to be able to interact with that data that's coming in. But that data needs to be, or that storage capacity needs to be reliable and redundant in order to be able to move back and forth. So a key defining new type of data center application, or data center type of performance, that's still early on, but it's going to be shifted out into the edge. And what we are bringing to market, and first to bring to market in our AI edge inference computers, is being able to leverage storage in terms of NVMe technology versus what traditionally has been SATA for so long. And SATA has been that 6 gigabit speed, but with NVMe, which is non-volatile memory express, you're now able to deliver read and write speeds for storage for access in extremely fast PCIe type of architecture. So, our AI edge inference computers on that data pipeline sits on that left side, right? They've been hardened and ruggedized that really kind of deliver mobile and remote edge compute. But they're also providing the valuable data storage that needed for the machine intelligence and inference and data aggregation. And kind of as a whole, right, it's a consolidation of like the latest compute storage connectivity with the ruggedization mechanical engineering that we leverage in our 30 plus years of experience into a solid solution at the edge. But if you think about that data pipeline once more, if you go to kind of the far right of that, or not even far right, where the cloud, because the cloud is kind of in that controlled environment, right? When we're talking about that far near edge, we also have a solution, which we have talked about in past podcasts, is kind of what is a 5G access server. And this 5G access server is what we are calling our DPU accelerated server. And this is where this type of solution is sitting close to the telco base stations. It's sitting at these nano data centers, sitting at these micro data centers. And it's basically being able to deal with the mission critical data that needs to be passed from that mobile endpoint back to some element where it needs a little bit of robust power, additional power to run another type of layer of machine learning, or just another type of processing power, connectivity power for that application. So in our DPU accelerated server, it's a very unique design, and I suggest listeners who are interested in our DPU server to go kind of check it out, because it definitely is very unique in terms of the growth of edge compute in far and edge. But it's able to basically leverage a lot of this new FPGA technology, smart network cards, and DPUs that are able to kind of remove the processing power without taking a step back to the CPU. So once the data packets from the edge hit this type of information, these DPU or SmartNICs or FPGAs can basically interact with data, deliver data, process data very quickly without having to leverage the CPU. And what this does is that heavily decreases the latency, and all latency in terms of where it even sits in terms of the overall data pipeline is extremely beneficial, because now you can push all that information back out for what it needs. So I think those two type of solutions that I'm talking about here in terms of the data pipeline, closer to where data is generated with Premio's AI edge inference computers, and then closer to the far edge, which is more of your 2U12 rack mountable DPU accelerated server. I think a combination of those two is really kind of a good starting place to help audience members really understand kind of the bandwidth that Premio has in terms of our hardware knowledge and expertise in this market.
All right, Dustin, last question I've got for you then is just to I guess, end on a wider note here. I'm curious what market motivators you think are going to grow both the edge closer to home as well as some of the furthest reaches of the edge, and how you think companies with both near and far deployments should start to prepare for some of these changes. Basically, peer into the crystal ball for us, tell us what's to come.
I wish I had that answer. If I had that answer, I probably could make lots and lots and lots of money, but I do not.
Same.
Yeah. So from Premio's perspective, I always just provide thought leadership based on what we see from our customers and what we know. And what we know for the last 30 plus years has always been hardware. But not only just looking at the hardware, I think it's important to recap on kind of what I talked about in this thought leadership, right? Let's see where the growth of cloud native computing moves out to the edge. Like, how are you going to use these resources closer to the telco data or the telco base stations or the cell towers? And let's see the rollout of 5G. Let's see how 5G is going to create more opportunity. I mean, 5G is going to definitely have its start in kind of a lot of these private networks, or these private enterprises to build out their own 5G networks. Let's see where it grows into in terms of a mass consumer standpoint and what new opportunities that are coming from that. And then let's see what AI, what everyone's been talking about, AI is going to continue to grow, right? I think in terms of the overall business, right, looking at that crystal ball, I would say there's not one type of customer, or I shouldn't say that. There's not one type of vendor or one type of solution that's going to be the silver bullet that solves all. And I think this is why this industry is so robust. And I think it relies on a lot of ecosystem partners. And those key ecosystem partners really work all together to really kind of drive the market forward. And I think that has been proven in the pandemic, during this pandemic, to show why technology is so important. So I think it's a combination of an ecosystem of, ecosystem partners in connectivity, hardware, software, and then services as a whole. And that's really going to push this new market forward for edge compute and just kind of data aggregation and machine learning. So one little kind of takeaway is that a lot of these analysts are projecting that with all the growth of this ecosystem and all these vendors working together to drive solutions, I think by 2023 this market's supposed to be valued around like $500 billion, which I think is incredible.
That is pretty incredible. And hey, if you do get that crystal ball, hit me up because, the almighty dollar talks. All right, Mr. Dustin, thank you so much for your thought leadership today. It's really been a pleasure breaking this down and getting to explore the differences between the near edge and the far edge and how they tie into some of the larger technologies, the cutting edge ones that are driving edge computing forward. I think it's always important to understand that as we talk about some of these distinctions within edge computing and the rugged edge, these things are being shaped actively by markets investing in new use cases, by technology improvements, and by even things like consumer devices and those applications pushing investments by municipalities, by the federal government. I mean, there's so many market motivators, right? So it's important for us to stay on top of these conversations and to understand that the near edge and the far edge may continue to get redefined. So stay tuned to Premio's podcast and our various live pieces of content, because we're going to keep these conversations flowing so we stay up to date with future changes. All that being said, Dustin, thank you so much for your time today. Again, we've been chatting with Dustin Seetoo, Director of Product Marketing for Premio. And Dustin, if folks want to find out more about how Premio is supporting the near edge and the far edge, maybe they want a refresher on some of those distinctions, how can they get in touch? Where can they find more resources?
Yeah, so the number one best place is to hit up our website, premioinc.com. But I think one of the biggest takeaways from this 1 year in terms of what we put together for the market in terms of educational resources is we do have a free ebook that really kind of dives into what we have defined as rugged edge computing. So I encourage everyone to go out there. Please download the ebook. It's free. I think you can learn a lot and really kind of take a lot of this thought leadership, package it together to kind of help you define what your strategies will be for edge compute or what type of solutions you may need for the future. So thank you very much, everyone.
Fantastic. Dustin, thank you so much for your time. We'll chat again soon, I'm sure.
Thank you. Have a good one, everyone.
And thank you everyone for watching this live episode of the Rugged Edge Survival Guide, a Premio podcast. If you like what you heard and saw today and you want some previous episodes where we explore, again, major changes to edge computing and the rugged edge, make sure that you're subscribing to our podcast on Apple Podcasts and Spotify, and head to our website, premioinc.com. Again, premioinc.com for more. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on the next episode of the Rugged Edge Survival Guide.